Okay, so this is a very, very short video, just introducing the idea of vector valued functions. Okay, so really this is something that's not new. We're just kind of ratcheting it up a bit. We saw these in BC Calculus. We're going to see them in ACalc, but now we're going to add more dimensions to this. So we're going to let f, g, and h be ordinary functions. So these are just functions as we know them that map a real number into another real number. So there's nothing special about those. So now we're going to create a vector valued function. We're going to call it r. And it's going to map from the real numbers to the three-dimensional vector. So we're going to say that r has a parameter t, and that it is comprised of f of t, so that's the first coordinate, g of t, which is the second coordinate, and h of t, which is the third coordinate. Now, generally speaking, we're going to be working in R3 in this class, but there's nothing about this definition that says that I can't have more functions and more components to my vector and make it a 4, 5, 9, 72-dimensional vector. But for all intents and purposes in this class, we're going to work kind of like with the physics model, which is R3. Okay, so basically here we call this a vector valued function. So it eats some real number t and it spits out a vector. So its value is a vector. Okay, when you graph these in space, so when I'm in the 3 space x, y, z, and if I graph this as a set of position vectors, I'm actually going to get like some sort of curve that goes through space. So it's kind of like a particle moving in time. Okay, so it'd be like a t1, t2, tn, so forth and so on. So it's going to be like the pathway of a particle through space. All right, so that's it. That's the beginning of vector valued functions, and we'll go from there.